Welcome to Machine Vision's Next Leap, a special edition of AI Frontiers. Today we distill the latest breakthroughs in computer vision and pattern recognition, summarizing 64 pivotal papers published on a single day. Prepare to discover emerging trends in visual intelligence, spotlight transformative research, and preview key topics shaping the future of machine perception. Stay tuned for our paper of the day and a comprehensive look at the state of the field. This presentation offers a guided journey through the fast-moving landscape of machine vision. The discussion will set the stage by contextualizing recent advances in computer vision, then examine dominant research themes and major technical leaps. 3 seminal papers will be explored in depth to highlight their impact. Methodologies powering these advances will be unpacked, and future research directions outlined. The session concludes with an AI-powered synthesis and actionable next steps for researchers and practitioners alike. Computer vision and pattern recognition represent the scientific and technical foundation for enabling machines to interpret images and videos. These technologies drive applications such as facial recognition, advanced medical diagnostics, and the visual perception systems in autonomous vehicles. At their core, these methods allow machines to reason visually about the world, serving as a central pillar for achieving human-like understanding in artificial intelligence. Their influence extends across scientific research, industrial innovation, and societal transformation. The first major theme is multimodal and multisensor fusion. Researchers are increasingly integrating visual information with language, audio, radar, and satellite data to enhance machine perception. Notable work includes TerraFM, which unifies radar and optical satellite data for comprehensive Earth observation, and Clamor, which combines video frames, speech, and text for robust video content retrieval. Multimodal fusion significantly boosts system robustness and adaptability, addressing the inherent noise and gaps found in real-world data. This fusion is essential for building resilient and versatile AI systems. The second theme centers on foundation models and large-scale benchmarks. Foundation models are versatile, reusable AI systems trained on vast datasets, enabling broad generalization and transfer across tasks. Examples include STARFlow, which demonstrates scalable image synthesis using normalizing flows, and the Movie Facts and Fibs benchmark, which sets a new standard for evaluating deep narrative understanding. The combination of large models and extensive datasets is fueling the development of more generalizable and transferable machine vision capabilities, establishing the necessary scaffolding for future advances. The third research theme is vision-language reasoning and the pursuit of human-like intelligence. The field is advancing beyond basic image captioning, focusing on nuanced visual reasoning and contextual understanding. Models such as CoMemo and Exact align complex visual inputs with expert-level language queries. The IDEOCHAT-A1 exemplifies this progress by chaining reasoning across video shots, enabling the handling of ambiguous, context-dependent, and long-range queries. These advances mark a significant step toward achieving true, multimodal, and human-like intelligence in computer vision systems. The fourth theme addresses domain-specific applications and the drive for efficiency. Computer vision technologies are being tailored for critical areas such as medicine, agriculture, and autonomous driving. The HMVLM model introduces multi-view and multi-stage reasoning for enhanced safety in driving scenarios, while the Visual Graph Arena dataset probes models' abilities for conceptual understanding using graph structures. Efforts to develop lighter models and efficient data streaming are enabling real-world deployment. Key research goals include improving reliability, scalability, and robustness to ensure practical impact. Key findings from the recent literature highlight several significant advancements. TerraFM demonstrates global generalization in Earth monitoring by effectively integrating multi-sensor data. The IDEOCHAT-A1 achieves efficient, chain-of-shot video reasoning, setting new standards for long video understanding. The HNVLM framework brings human-like multi-stage reasoning to autonomous driving, prioritizing both accuracy and interpretability. STARFlow illustrates that normalizing flows can now rival diffusion models in high-resolution image synthesis. The Visual Graph Arena exposes ongoing challenges, revealing AI's struggle with tasks that require true abstraction and conceptual understanding. Several methodological breakthroughs underpin recent progress in machine vision. Self-supervised learning, as used in TerraFM, allows models to learn from vast amounts of unlabeled data. Contrastive learning techniques enable the distinction between similar and dissimilar examples, enhancing representation quality. Transformers and attention-based architectures excel at integrating long-range and multimodal signals. Multimodal fusion can be implemented through early, late, or cross-attention strategies. Rigorous benchmarking with realistic tasks and new evaluation metrics is driving advances in model performance and robustness. The first highlighted paper is TerraFM, a scalable foundation model for unified multisensor Earth observation, authored by Danish and colleagues in 2025. This work addresses the challenge of achieving global generalization across both radar and optical data sources. The model employs an adaptive cross-attention mechanism to fuse multiple sensor modalities, effectively preserving and integrating their unique characteristics. A dual centering approach is introduced to improve the recognition of rare land cover classes. The impact of TerraFM is substantial, accelerating progress in climate science, agriculture monitoring, and disaster response through its robust and transferable representations. The second selected paper is VIDEOCHAT-A1, Thinking with Long Videos by Chain of Shot Reasoning, presented by Wang and collaborators in 2025. This model segments long videos, identifies key shots, and chains reasoning across those segments. Multimodal fusion is achieved by integrating visual, audio, and textual data, enhancing the depth of understanding. VIDEOCHAT-A1 achieves state-of-the-art accuracy and efficiency for long video question answering, significantly reducing computation time and resource requirements. The impact of this work moves video understanding closer to human-like intelligence, with practical applications in education, security, and entertainment. The third paper spotlight is STARFlow, Scaling Latent Normalizing Flows for High-Resolution Image Synthesis, authored by Gu and team in 2025. STARFlow introduces a hybrid architecture combining deep and shallow transformer blocks and operates in the latent space of a pre-trained autoencoder to improve efficiency and sample quality. A guidance algorithm, adapted for normalizing flows, further enhances sample fidelity. The result is a generative model that brings normalizing flows to the frontier of image synthesis, matching or surpassing the performance of diffusion models. STARFlow expands the possibilities for controllable and interpretable image generation in high-resolution settings. Looking to the future, computer vision research is expected to prioritize more sophisticated strategies for multimodal and temporal fusion. Foundation models tailored for specialized domains such as medicine and geoscience are anticipated to emerge. Evaluation metrics will increasingly focus on conceptualization, reliability, and robustness rather than raw accuracy alone. Explainability and efficiency will become essential for deployment in real-world contexts. A central challenge remains: bridging the gap between AI conceptualization and the flexibility of human abstraction, ensuring that machine systems approach the depth of human visual reasoning. This synthesis and review have been powered by GPT 4.1 from OpenAI for narrative construction and analysis. Text-to-speech audio was generated using DeepGram, and supporting images were produced with OpenAI's generative models. All synthesized content has been reviewed by human experts to ensure accuracy and balance, though the potential for oversights remains. Full references for all discussed research are provided. This approach ensures a cross-validated, comprehensive summary of cutting-edge developments in computer vision and pattern recognition. In this podcast, the latest breakthroughs in computer science and AI are brought to you directly from the arXiv preprint server. Topics range from neural networks to quantum computing, translating complex research into accessible insights so listeners can remain at the forefront of technological progress. Whether the audience consists of developers, researchers, or technology enthusiasts, AI Frontiers delivers daily in-depth coverage. Thank you for listening. To stay updated with ongoing advances, please subscribe for daily updates. Tomorrow will bring more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.